Welcome to Experimental, the science show that hugs you down the phone and drives your dog wild with excitement. Later on, we'll be using science to blast away at the secrets of this magician, inflicting 3-year-old sandwiches on the good people of Natick, Massachusetts, and examining the physical properties of a raspberry at 500 frames a second. But first, let's snuggle up closer together. Rome, Rome, wonderful Rome. The Colosseum, the Trevi Fountain, daredevil drivers, feral cats. And of course, it's one of the world's most romantic cities. A fitting backdrop for a piece of fashion that aims to keep you in touch with your main squeeze. Literally.
Ooh!
We're gonna fly!
It's funny!
It's an inflatable shirt that allows you to send and receive hugs via text messages on your mobile phone.
Squeeze! Oh, like someone's properly holding me in their arms.
And its inventors, Francesca Rosella and Ryan Gentz, believe that in the future we'll all be wearing clothing like this.
I've always had a passion for fashion, and I've been also a fashion designer for a long time. But I also had a passion for technology, and I tried to combine both.
The shirt was designed to demonstrate how mobile phone technology could be integrated into clothing. But it's been so popular that Francesca and Ryan are now ready to market it.
We get requests almost on a daily basis from people that want to sell the shirt and people that want to buy the shirt for a huge amount of reasons, like reasons that we couldn't even have come up with in our research.
The Hug shirt contains a series of carefully positioned touch-sensitive pads. To send a hug, you open a special function on your phone and you give yourself a great big hug. An onboard computer records the strength and position of your hands and turns the data into a simple text message. At the receiving end, the text arrives. And if you like the sound of the sender, you choose to receive it. A tiny air pump fills the air pads to give the correct squeeze strength. And if that's not enough, the shirt even warms up to mimic the body heat of the sender. Ah, lovely. The company behind the invention is the techno fashion house Cute Circuit, run by real-life hugging partners Francesca and Ryan.
All the technology to develop this sort of thing is available today, and we already have working prototypes.
But how do you turn a circuit board into a hug? Ryan and Francesca started with t-shirts and pens, taking over 50 volunteers and drawing circles around their hands. Amazingly, they found out that we all hug the same. The final stage was to work out what a really good hug feels like and mold the technology to replicate it.
The result is like this package of technology. There is a sensor that is a very tiny flat sensor, like this one, that feels how strong you're hugging. And then inside there is a little pump here. And when I receive a hug, this pump starts to inflate a little balloon.
Ah, isn't that sweet? The cutting edge of 21st century hugging technology. But before all you cynics turn off, why not ponder on this fact? Hugging may actually help you live a longer, happier and healthier life. Studies have shown that hugging causes the brain to release hormones that make you feel relaxed and happy. Hugging also leads to a reduction in the release of stress hormones, chemicals that are linked to heart attacks. And this could explain why single people are more likely to get heart attacks than people in loving relationships. So it's a potent thing, this hugging, but would it convince you to buy Francesca's techno shirt?
Yes, definitely.
Yeah, that would be great. If this invention was available, I would probably like to send some hugs to my son when I'm not with him.
One for her, one for my son, then I can just keep text messaging hugs every night.
This is amazing.
All the fashion people say, oh, we're never going to put technology into our clothes. And all the telecommunication people say, it has just to work, it doesn't have to look good. And instead, we're like merging these two things together, make them look really, really good, and give them an emotional value that really makes people think that is great to use.
Before the amazing Alim Amlani does strange things with a $5 note and an orange, let's head to the test department for some of the hottest science on television. Despite its popularity, there are some people who just cannot cope with a good curry. But there must be a better way to cool your mouth. To find out, we're going to test the effects of 3 curry house coolers: water, beer, and that yogurt drink most tea-drinking Brits can't handle. But first, we have to set a benchmark. Our demonstrators here will each chew on a chilli and score the pain out of 10. That's quite hot then. The sensation of spiciness is caused by the chemical compound capsaicin. But it doesn't actually burn the mouth at all. What it does is to bind to nerve receptors in the mouth that normally sense temperature. These nerves are stimulated and tell the brain that the mouth is being burnt. So even though we feel the pain, it's not actually burning you in the conventional sense. With this in mind, let's test the effectiveness of our 3 cooling drinks. So yogurt is the clear winner. And the reason? Fat. Capsaicin is soluble in fat, not water. And the milk in yogurt contains loads of fat, which dissolves the capsaicin and carries it safely away from your sensitive nerves. Perfect. So there it is. Stay away from the lager and go for a milky drink next time you go for a curry. Coming your way on Experimental, the scientist who believes every dog needs a mobile phone, and how the US Army get away with feeding their soldiers 3-year-old sandwiches. Experimental has travelled all the way to Vancouver to visit the University of British Columbia's Visual Cognition Labs, where they use a lot of fancy kit to examine something that might appear fairly trivial. And that is why magicians like research assistant Alim Amlani can pull off stunts like this. Just watch.
What I have over here is a piece of rope. Could you examine that? Sure. And could I borrow your ring for a moment? Sure. Perfect.
A lot of the time, people aren't aware of everything happening in front of them, and what magicians are able to do is exploit that.
The ring right over here goes onto the piece of rope, just like that.
So things that are right in front of you sometimes go unseen.
Now, it really is on the rope. You can tug on that if you want.
What magicians have been doing is they're able to basically direct attention around a scene. So even though you're going to be looking at one thing, something could be happening right in front of your face and you wouldn't even see it.
Now, what I'm going to do is I'm going to give you this end over here, don't let go. You take this end over here and don't let go. I can slide the ring this way, I can slide the ring this way, but what I cannot do is pull it off just like that. I cannot make it disappear just like that and land back on the finger just like that.
Alim knows exactly how his trick works. He just won't show us. Back at the Visual Cognition Lab, Dr. Ronald Rensick has a word for why people do not see what's in front of them. He calls it change blindness.
Change blindness is really the effect where people don't see large changes that are in front of them. These are changes that are very easily seen once you see them, but it takes a long, long time before people see them. Until they do, they're effectively blind, hence change blindness.
To prove how it works, Dr. Rensick and his fellow researchers have devised a number of tests to see exactly where we look. Tiny cameras track the movement of the pupil and plot the centre of their gaze on the image being viewed. The results were fascinating to researcher Elena Birmingham.
We found that overall, people looked mostly at the eyes. So even though there are many objects to look at in the scene, they look primarily at the eye regions, which is a novel finding.
Just to prove how blind we are, watch this classic experiment. A student is asked to undertake a simple task, completing a questionnaire. As she works, the researcher, who she met for the first time a few moments ago, changes place with another. But will the student notice?
I think I'm done with this one.
Great. Thanks. Did you notice anything unusual about the experiment?
No.
Did you notice that me and another experimenter switched places halfway through?
Oh, no, I didn't notice that at all.
Now you may think that's impossible. But to prove how blind you really are, let's look at the ring trick again. Remember when the magician revealed the ring was on his finger?
I cannot make it disappear just like that and land back on the finger just like that.
That wasn't magic. If you'd only been watching, you'd have seen it was there all along.
I cannot make it disappear just like that and land back on the finger.
So why does this happen? Well, some scientists think it's all to do with your posterior parietal cortex, a little bit of the brain that's near the back. It's the bit that deals with short-term visual memory. Unfortunately, it's not big enough to process all the information sent to it, so it does something rather clever. It remembers just enough of the important things in an image to be able to recognize it again. So just like this, you blink, you open your eyes again, and so long as everything looks pretty much as it did a few milliseconds before, the brain will assume that nothing has changed. Even if it has. Did you notice the shadow beneath the Jeep coming and going? Probably not.
Inherently, we're susceptible to this. There's not that much we can do. All we can do is try to design our technology to minimize the possibility of this happening.
Just to show how susceptible we are to change blindness, watch this next trick very closely.
Could I borrow a $5 bill? Maybe could you just sign your name across the bill? Okay. Have you ever seen the trick, Eric, where the magician takes the bill, folds it up nice and small, and when he unfolds the bill, it is a $100 bill?
No, but I'd like to see it.
Too bad. Can you still feel your bill, by the way? All right, what we're going to try to do is something amazing. Watch. 1, 2, 3.
Okay. Where'd it go?
What I have over here is a knife. And you can see the orange sealed on all sides. Inside this orange, right over here.
What? Eric, that's not my bill.
Take that out, take a look. Can you show that to the camera?
Gosh.
Is that your name?
Yeah.
Thank you guys very, very much.
You do that.
Did you see how he did it? No? Well, don't feel bad. Nor did we. But did you see the big gorilla halfway through? Well, just in case you didn't, here it is again.
And you can see the orange sealed on all sides. Inside this orange,
don't try this at home.
Still to come on Experimental, mobile phones for dogs, gourmet sandwiches for grunts, and the phantom raspberry blower. But first, welcome to the Great Test Department Grip Experiment, in which our 3 intrepid testers are going to find out which type of shoe has the best grip. Will it be number 1, the cheap plastic flip-flops from a seaside novelty store? Or number 2, professional leather-soled ballet shoes? Or finally number 3, a pair of expensive mountaineering boots that are guaranteed to get you up Everest the hard way? Whilst the gamblers amongst you are laying out your bets, let us ready the Test Department slipometer. Or rather, an electric drill, some rope, and some planks of wood. The idea is we can gradually increase the slope until our test department tester slips downwards. First up, those sturdy mountaineering boots. "5 degrees, 10, 20, 25, oh, and a slip at 35 degrees, but as expected, they're pretty good. Next, those natty little ballet shoes. All set, go. 5, 10, 15, 20, this is not bad, but hang on, oh, they've gone at just 27.5 degrees. Well, well. And finally, those cheapo flip-flops. Here we go, straight through 5 and 10 degrees, 15, 20, 25, 30. This is amazing. They've reached a staggering 40 degrees. What a turn up for the books. So next time you're scaling the Eiger face, why not bin the boots and try a pair of £1.99 flip-flops instead? Did I hear the word frostbite? Coming up on Experimental, techie stuff for dogs and violence in the test department. But before all that, let's go snacking with the army.
Hello.
Here we are in Natick, Massachusetts, trying out a new kind of sandwich.
Yeah, it's good.
Not bad.
I like it.
It's a good thing they like it because this isn't an ordinary sandwich. These are high-tech sandwiches from a special batch made by the US military. Behold, the Forever Sandwich. The idea behind the sandwich is to make sure the infantry don't waste valuable fighting time messing around with mess tins. Instead, they eat on the run. Why? Well, it's hard to tell exactly when the boys in green are going to need to get out their guns and fight, so a ready supply of munchies must always be on hand. That's part of Michelle Richardson's job. She's from the Department of Defense Combat Feeding Directorate, and she was on the team which came up with this cunning plan.
This is a shelf-stable pocket sandwich. It's called shelf-stable because it has a 3-year shelf life. This is something that the soldier can't eat out of hand, doesn't require any preparation, and he can eat while on the move if needed.
But the bread is remarkable. Ultra-pasteurized, radioactive, sealed against the elements. How do you do that?
A lot of the stuff that goes in the bread is pretty common, such as mono and diglycerides to stop it getting stale, and ascorbic acid to stop the mold. So much for the bread. But what about the middle of the sandwich? Well, that too has a healthy squirt of glycerol to stop the bacteria growing, plus a few other unpronounceables which do much the same thing. But the key is not the chemicals in the sandwich, but the packaging. Not only is it more airtight than a tin can, but it contains a little package of oxygen-scavenging chemicals. Each of the sachets is filled with a chemical such as iron oxide, a molecule with a need for more oxygen atoms to keep it happy. Its effect is like a vacuum cleaner, sucking up any stray oxygen atoms it can get hold of. It's so effective that oxygen levels can be reduced to about 100 parts per million. The result is that all the molds and other bacteria that need oxygen to live effectively suffocate. So just how long can one of these things last?
Food items should be able to last for 3 years at 80 degrees.
Yes, these babies can last 3 years in the field, rain, sleet, sludge, and enemy fire. And just to prove it, these are from the Department of Defense's original batch, baked in April 2003.
Wow. Okay. Oh, goodness gracious.
Packed in here for 3 years? Why is it 3 years old?
And you're still eating. You didn't stop.
Isn't it amazing what science can do to us?
Whilst humans seem quite happy with this historic meal, other species seem a bit more choosy. Still to come on Experimental, the gizmo that got Fido here a little overexcited. But first, to the test department. What is it about blowing a raspberry that makes the raspberry sound? The test department decided to find out. We ran a series of medical tests on this prodigious raspberry blower. In a marathon session, our subject blew over 300 raspberries in just 1 hour, allowing the test department to draw a startling scientific conclusion. But what was it? It was that raspberry blowing is extremely annoying. A discovery which blew our demonstrator's mind but was hardly science. So, we got out our special 500 frame a second camera to have a closer look at what's going on. Revealed for the first time on your TV, the startling fact that it is the bottom lip that plays the dominant role in raspberry vibration. And for all that our raspberry blower has advanced the knowledge of humankind, we couldn't resist taking our revenge on the rude little squirt. Welcome to Scottsdale, Arizona. It's a pretty typical town, full of some of the good things about America. Like mobile phones, and some of the odd things about America, such as this woman and her dog.
And those guys. Yeah, she's pampered. Do we love her? We adore her. This is my passion.
So why is experimental here? Well, it's to meet this man, Cameron Robb, who's decided that the next big thing for a dog should be a phone.
I came up with the idea for a pet cell several years ago. I was on a business trip and I was talking to my daughter on the phone and she was telling me a story about her friend losing her dog.
Yep, every cloud has a silver lining. Buddy may have run off and broken a few hearts along the way, but it got Cameron thinking. Pretty soon, he'd come up with, well, a Fido phone.
I just felt with technology advancements, wireless telephones and tracking devices, it would be a great product to come up with for finding a dog.
Just like the modern human phone with its WAPs, Bluetooth and MP3 abilities, actually talking is fairly low on the Fido phone's list. Key to this gizmo is the fact that it can be tracked from space. So as Buddy heads for a raid on the local canine sweetie shop, a big red blotch appears on his owner's computer screen, prompting some swift action. Even better, his position can be uploaded live onto your own tracking device. So when Buddy heads to the hills with his loot, the posse can be close behind. The device does also work as a phone, so your favourite animal can hear all the exciting things you've got in store for him when you get home.
Hey Sam, it's Mom.
I'm almost done working now, so as soon as I get home, I'll take it for a run and we'll head over to the park.
So, thanks
for being a good boy, and I'll talk to you soon.
But unfortunately, all that talk of parks can get some dogs overexcited.
I love you.
Bye-bye.
Welcome to Experimental, the science show that collects earwax and creates boy bands. In a moment, we'll be sniffing a few cows in California, helping Billy grow his hair with stinging nettles, finding out how Nelson's wee-wee got into Toby's wine, and making a mechanical bird or two in deepest Florida. But first, have you ever wondered why Asian women have small breasts? Chinatown in London. The experimental team is getting to grips with a sticky problem. That's right, the earwax of Southeast Asia.
This one.
That one. It's like that.
See that one?
That one? Half.
Half and half. Really?
Yes, there's a difference between European earwax and that found in much of Asia. And the world expert on the subject is this man, Dr. Koshiri Yoshiro from the University of Nagasaki. His work with earwax is helping us to understand how early humans conquered the world. Earwax and global domination.
There are two types of earwax in the human being. One is dry type, like this, a powder-like substance that is frequently seen among East Asians. And the other one is wet type, sticky, like this. Yeah, this is common among Caucasians and Black Africans. Yeah, something like this.
Intrigued by this geographical phenomenon, Dr. Yoshiro asked colleagues around the world to collect nail clippings and blood samples from just about every ethnic group on the planet. They analysed the DNA from each sample, fed it into a computer, and looked to find out if there was a genetic difference between people with dry earwax and people with wet wax.
We found that a single gene determines the visible human genetic trait. That is earwax. Yeah, that is surprising, I think. Yeah.
But the amazing thing was the distribution of this gene. It supported a controversial theory on how humans first conquered the Earth.
Well, the human being originated in Africa. They started to move from Africa to all of the world. That was 100,000 years ago.
Somewhere along the line, the dry earwax gene became dominant amongst humans living in China, Japan, and much of Southeast Asia. Then, around 85,000 years ago, something happened which made some of these people cross to North America. The first of the waves of immigration that brought the dry earwax gene at least as far south as Bolivia.
Our experiment showed that the Chinese, Japanese, Koreans, Native Americans, and some Bolivians have a common ancestor. They were living around Lake Baikal 20,000 years ago.
Rather surprisingly, the dry earwax gene is responsible for some other rather personal traits.
Do you use deodorant? No. You don't use deodorant?
No. No.
You don't?
No.
Yep, you've guessed it. In the same way as the gene blocks the production of earwax, it also blocks the production of stinky sweat. This might explain why deodorants don't sell too well in Japan.
Okay, I smelled your under here. No. Okay.
But Dr. Yoshiro believes that his earwax gene has something even more surprising up its sleeve.
I believe that Asian women have a smaller breast size than other women, for example, Caucasians and Black people. So the size of the breast tissue, I believe that this is related to dry earwax.
But how to prove Dr. Yoshiro's theory?
Could I touch your... Not even just a little bit?
No.
Oh, go on, I'll pretend.
No.
No?
No, don't.
Definitely not?
No.
Still to come on Experimental, how to turn instant boy bands into instant fighter pilots. And how these birds might help them get better planes to fly in. But first, let's see just how stupid Billy Bunter is prepared to be in the name of science. Every now and again in the life of a scientist, young and not so young, one comes across the work of a colleague that will literally change your life. And this is that moment for Billy Bunter. You see, he's just come across US patent number 6596266, a potion to cure male pattern baldness using nettles. It's just what Billy needs. Perhaps that highly strung demonstrator Karina will fall for him with a full head of hair. True to the test department's ethos, why buy it when you can make it, Billy hightails it off to the garden in search of the ingredients, and soon he's boiling it all up and dreaming of a new quiff. But what is male pattern balding? Well, it seems to be a genetic characteristic, and it's caused by the hormone that makes men big and hairy in the first place, testosterone. There are enzymes in the body which change testosterone into another hormone, dihydrotestosterone. And it's this hormone that leads to the hair follicle shrinking and ultimately falling out. There's a chemical in nettles that's part of this potion which claims to prevent the change from testosterone to dihydrotestosterone and perhaps result in a healthy head of hair. So let's see if it works. Well, Billy, if you'd bothered to read the whole patent, you'd have noticed that the required chemical is found mainly in the roots, not the leaves, and is only part of the brew. Coming up later on Experimental, the planet-killing cows of California, and the aeroplane that thinks it's a bird. But first, a tactile vest from Holland. At Experimental, we heard that a Dutch company, TNO, were working on a new system that could help both boy bands and jet fighters strut their stuff. So we headed to Soesterberg in Utrecht, as fast as we could. When we looked through the door, it blew our minds. These three boys only met 20 minutes ago, and already they've got a dance routine worthy of the Eurovision Song Contest. This impressive feat was all down to their attire. This little number, the tactile vest, brainchild of Jan van Erp, with this man, Hendrik Jan van Veen.
The tactile vest is a display for your skin, very similar to the way a monitor or a set of headphones is a display for your eyes or for your ears.
Experimental has come across one or two things like this in the past, a hugging shirt of Rome, or the Singapore chicken vest. But this seems to be taking the idea to a different level. These guys are being controlled by a computer, switching on and off more than 100 of these little vibrators. All you have to do is react, and you can dance. Well, sort of. Luckily, inflicting the world with pre-programmed boy bands is not the only use for this tactile vest. Thanks, boys. Jan hopes that his electronics will soon be found in one of these.
A fighter pilot is a very busy pilot. He has to pay attention to many different systems and has to perform many tasks at the same time. Obviously, he has to fly the aircraft when it's not on autopilot. But he also has to deal with lots of different types of information, and it means that his eyes are really occupied by reading displays, looking outside, and doing different things.
By bringing touch into the equation with the tactile vest, Jan hopes to bring another sense to the fighter pilot's weapons. If their eyes or ears miss some vital information, like an incoming missile, a vibrating widget should alert them to the danger.
The principle we're using is the same principle as the one that you're used to, which is a tap on the shoulder. Somebody taps you on the shoulder, you know which way to look.
Well done, Biggles. But what's this chap doing in the shorts? Well, It's just another of Jan's uses for his tickly little vest. By hooking up his vibrators to a GPS system, he's managed to create a navigation device for cross-country runners. No more losing your rhythm checking the map. Just keep jogging until a little tickle sends you to the right or left. But whilst controlling butch men with vibrators might get some people excited, it seems that Experimental finds tickling boy bands the most fun.
Don't try this at home.
In a moment, we'll be trying to lift a test department tester with a glass of water, going bird watching in Florida, and sniffing cow whiff in California. But first, let's head to the test department to take mathematics a little too far. Down at the test department, Toby is getting all morbid. It's the birthday of his greatest hero, the British Admiral Lord Nelson, who died over 200 years ago.
Hello. Bonjour.
Still, he's trying to convince Horace that it remains possible to be at one with a great man. Toby's argument is based on the following facts. Every time Nelson breathed out, approximately 2.4 times 10 to the 22, yes, 22 noughts, molecules of gas came out of his mouth. And the fact that there are about 1.04 times 10 to the 44 molecules of gas in the Earth's atmosphere, Toby has worked out that this will mean that approximately 5.4 molecules of the gases that were once in Nelson's last breath will be in each breath of his. Whilst he's feeling a bit chuffed with himself, Horace is doing some calculations of his own. Given the fact that there are about 5.7 times 10 to the 46 water molecules on Earth, and that Nelson would have drunk about 52,000 litres of the stuff in his life, there's a good chance that Toby's glass of wine will contain an awful lot of the atoms that were once part of Nelson's urine. On its way, the ultimate boy's toy, the plane that thinks it's a bird. And fun things to do with a hot water bottle. But first, what's choking the planet? This might seem a green and pleasant land, but it's not. Look up to the hills, and you'll see they're all clouded in the asthmatic's favourite, smog. A nasty mix of gases made up of what scientists like to call volatile organic compounds. Welcome to the most polluted valley in California, San Joaquin. And what's causing all that yellow muck? Well, there are the common suspects, heavy industry plus 6-lane highways choked with SUVs, but there are some who claim there's another villain. It's Daisy the cow, and over 3 million of her ruminating friends who also live in the valley. That's right, 3.2 million cows means 3.2 million bums doing this. According to some, each of the cows manages to push out as much polluting gases as, what, 1 car? 2 perhaps? Well, no. The annual figure bandied about for the output of Daisy's gastric tract is said to be the equivalent of the output of no less than 85 cars. And it's not really her fault. Like any mammal, the amount of wind she produces is influenced in part by her diet, and unfortunately for her, she mainly eats grass, which is one of the hardest foods to digest. So hard that if we saw Daisy in half, we'll find a stomach with 4 parts, each filled with billions of bacteria, which ferment all that green stuff, until they've managed to turn it into something that Daisy can actually digest. And it's all that fermentation that produces the nasty gases that pass from Daisy's front end to her rear end. So far, so repellent. But can we really blame cows for producing all that nasty yellow haze? Well, that's what this man, Frank Mitterlau, from the University of California, Davis, wanted to find out. The figure for Daisy's polluting habits comes from a study done way back in 1938. At the time, they thought the smog was largely produced by methane, and since cows produce a lot of methane, the blame was laid on them. But now we know that smog is made up of a cocktail of volatile organic compounds, or VOCs. And they're found in everything from exhaust fumes to paint or underarm deodorants. And yes, they are found in the stuff that flies out of the back of Daisy.
So what we are doing is we are trying to measure these hundreds of different VOC, volatile organic compounds, that form smog.
Welcome to the world's largest fart chamber, the UC Davis biobubbles. The bovine equivalent of that old jam jar in the bath trick. If you don't understand that, ladies, just ask your boyfriends about it.
We use the biobubbles to house animals to measure air quality impacts. We have one air inlet on the one side and an air outlet on the other side. And the difference between outlet and inlet is what the animals and their waste and the animal feed produces by means of air emissions. So what we're finding is that in general our total emission numbers are much lower, those that are currently on the books.
How much lower? Well, Dr. Mittelauer's provisional results indicate that in 1 year, one cow does not produce the same amount of VOCs as 85 cars. No, it's closer to 10 cars, which is still a lot. But hey, if you want cheese, milk and yogurt, you're going to need cows. So, if you're concerned about the smog, why don't you carpool, take the bus, or better still, walk. But whatever you do, lay off the beans yourself. Still to come on Experimental, the Morphing spy planes of California. But first, to the test department. Water is such fun. Often at test department towers, the team will frolic in it, play with it, and make drinks with it. Sometimes, they'll even cook up new and innovative uses for it, like using it to lift a person. How can this happen? Well, as you can see, water on its own is not very good at lifting anything. In fact, it's rather good at allowing things to sink through it. But if we were to put it into this fancy Water Bladder 3000 machine, and all of a sudden, water's lifting properties are revealed. To get the pressure up, all we have to do is pour the water into this pipe at a great height. There. So why did she rise? Well, it's all to do with the weight of a column of water. Imagine our little tube went all the way to the bottom of the deepest ocean. As our submarine drops into the depths, the pressure of the water increases the deeper it goes. By the time it gets to the bottom, at 10,660 meters, the pressure is a staggering 1,068 kilograms per square centimeter, enough to crush all but the toughest of subs. Even with the pressure of a 3-meter column of water pressing down on it, the pressure in our hot water bottle rises to 0.3 kilograms per square centimeter. Not only enough to lift a person, but also to blow holes in it. Meet Dr. Rick Lind and his team. Big boys with a little dream. The Morphing spy plane. They want to make a plane so maneuverable that it can fly over a city and ultimately swoop down and into a room.
The real application for aircraft is in urban operations or flying within a city. We can imagine if someone released a dangerous gas in downtown Los Angeles, we could have a small aircraft that could fly throughout the city into parking garages, between alleys, inside of buildings even, to look for this dangerous substance.
The plane needs to be not just small, it needs to be bird-like too.
Our real objective is to build airplanes that actually can do what birds do. They can fly where birds fly and do maneuvers like birds can maneuver.
Aeronautical engineers have always been inspired by birds, but until now most wings have been rigid and fixed, like this. But Dr. Lin's wings are flexible, and for good reason.
We have large airplanes that fly above the cities and high in the sky, but we need airplanes that can operate at treetop level or even car level.
And that's where all this flexibility comes in. It's about making the wing adapt to different situations. In both birds and planes, the shape of the wing determines what the beast can do. Long, thin wings are great for distance flying, but pretty useless when it comes to dodging around in small places. For that, you need short wings, but they're only good for short flights. To make the ultimate flying machine, you need a wing that can change to suit the conditions, long and thin to get you there, and short and stubby to whiz you around. King of the wing change is the seagull.
One of the first things we looked at was what shapes does the seagull change into during its flight. How does a seagull change its shoulders, elbows, its muscles, and its feathers when it wants to land versus taking off? How does a seagull change its shape to fly into a strong wind?
To find out exactly how they did it, Dr. Lin sent out a spy of his own who took thousands of pictures of birds in all aspects of flight.
The photographs that we're looking for are gliding pictures of birds. So you'll see that as the birds attempt different maneuvers, they'll change the shape of their wings to change the aerodynamics. And this is of particular interest to us because then we can mimic these shapes using mechanical actuators on our morphing airplanes and try to accomplish the same type of gliding capability.
Once they knew the wing shapes they wanted to mimic, the hard part really began.
Well, as you can see, we've installed motors and electronics on the airplane that will physically cause the wing to bend and rotate about the shoulder and elbow, just like a seagull would change its wing in flight.
But the real key to getting a wing to flex like a seagull's wasn't so much the actuators.
Our wing design differs from conventional airplanes mostly because it's a very, very thin wing. Because I have that thin wing, our wings can bend and twist in ways a large aircraft could not.
Okay, but can it actually fly? Pretty impressive. In fact, the boys are so confident that they've cracked bird flight that they're beginning to get a bit more relaxed about the type of birds they're observing down at the beach. And finally on Experimental, a cooking lesson from the test department. Toby here is keen to find out if eating asparagus can make your urine smell of the green-fingered vegetable within 15 minutes. So let's see if it's true. Well, now we've got a sample that, yes, seems to smell of asparagus, let's test it out on a random selection of the great British public. Sadly, the first two seem only to smell that standard urinal whiff. But the third, who does seem to be a bit of a plant, is convinced of the aroma.
Asparagus? Asparagus. I mean, very interesting.
Interestingly, Horace has been in the test department library digging out a few papers on the subject. You see, in 1952, scientists shoved asparagus-tinged wee under the noses of 115 people in the UK and found that only 40% could smell the whiff. The ability seemed to run in families. If you can smell it, it's quite possible, therefore, that your dad and granddad can too, which suggests that genetics might be involved. Even stranger, studies have shown that Israelis and Chinese people are far less likely to be able to smell asparagus in the wee-wee, even when it's definitely there, than Europeans are. However, despite over a century of studies, no one seems to be sure exactly what it is in the asparagus that makes the whiff.